This lesson is about Newton's laws. We're actually going to start with Newton's second law. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass of the object. We can express this relationship as the equation A equals F net over m. If we cross multiply, we get the more familiar form F net equals ma. For this reason, we will often refer to Newton's second law as just F equals ma. Mass is a measure of how much stuff something is made of. The unit for mass is kilogram. Weight and mass are not the same thing. Weight is the force due to gravity that's acting on an object. We'll talk more about that later on. Now we can figure out the units for force. If the unit for mass is kilograms, and the unit for acceleration is meters per second squared, then the units we end up with for forces are kilogram meters per second squared. Since that's quite a mouthful and a lot to write down, we can also refer to this as just a Newton, abbreviated with a capital N. In this video, a student demonstrates Newton's second law by blowing out a piece of popcorn at a bottle cap. Since the piece of popcorn has less mass, it experiences more acceleration and goes farther than the bottle cap. Now back to Newton's first law. Newton's first law states that an object with zero net force acting on it remains at rest or moves at constant speed in a straight line. Here's a video of a crash test. Though the car stops, since the dummy is not wearing a seatbelt, there's no forces exerted on it. Therefore, it continues moving at constant velocity in a straight line, directly into the steering wheel and the windshield. We say that this happens because the dummy has inertia. Inertia is a property of matter that causes an object to resist a change of motion. Newton's first law is often referred to as the law of inertia. And finally, Newton's third law. For every action, by which we mean a force, there is an equal and opposite reaction, or force. In other words, when two objects interact, the forces they exert on each other are equal in magnitude and opposite in direction. In this video, you can see that the girl on the hovercraft accelerates not only when she catches the ball, but when she throws the ball as well. When she catches the ball, she exerts a force on the ball to our left, causing it to stop. Because of Newton's third law, the ball must then exert a force on the girl to our right, causing her to accelerate. When she throws the ball, she exerts a force on it to the left. Therefore, the ball exerts a force on her to the right, causing her to accelerate once again. We call this an action-reaction pair, where the force of object A on object B is equal to the negative force of object B on object A. As a summary to this lesson, please watch the following video and explain what you see using one or more of Newton's laws.